the next video here is also still gonna be the multiplication of negative numbers, or at least two numbers, whereas at least one of those two numbers is a negative number. So we will start. I will take again, as in the previous case, let's take something that's different. Let's do 26 here. Let's do the multiplication of 26 by minus what number? Let's say 21. So now let's do the representation of 21. 21 is 16, is 20, 16 plus 4 plus 1. So I'll start with 21. We have in position 1 we'll have a 1. Then we have 20, that is 16 plus 4. So 4 is in position 3 here, and then 16 is in position right. So this is 16 plus 4 plus 1. This is 21, and then I append a 0 here in front. Now to find the value of minus 21, we do the 2's complement of 21. This will give us the 1, 0, 1, 0, 1, 0. Adding a 1 to that give us 1, 0, 1, 0, 1, and 1. So we have the value of 21. Let's put it of minus 21, pardon. So minus 21 corresponds to 1, 0, 1, 0, 1, 1. And then what is 26? 26 is, so 26 is 20 plus 6. So 20 will mean we'll have the same structure like we had previously. We'll have, so for 26, we won't have anything in bit 0. So not sure if we're going to have something in bit 1. So I'll hold off first. And then we'll have the 4, which is 26 is, yes, 24 plus 2, which means 24 is 16 plus 8. So I would have 0 here, then 0 there. I'll have 1 and 1. So that is 16 plus 4. And then we'll have a 2 to complete. So the 2 will give us a 1 here. So this is the representation of 26. And on minus 26, we'll just do the flip. 1, 0, 0, 1, 0, 1. And then adding a 1 give us the 0, 1, 1, 0, 0, and then 1. Am I correct? Yes, 1, 0, 1. Okay, so we have the value of 26, and now we can start our multiplication. So 26, 1, 0, 0, 1, 1, 0. That was 26, or we did we don't need to do the, since 26 is a positive number, we don't need to take the 2's complement. So let me revert that. So let's go back. Okay, the only thing we need to do here is to go with the 26, which is, we just need the 26. Okay, let's clean up a little bit. We have 26. I'll put my C as usual, the P, and then the Y. And here for the C is 0. We start in the 26. It's gonna be on 6th position. So we have 0, 0, 0, 0, 0, 0. And then the Y is also gonna be on 6th position, and we're initializing the Y with the minus 21. 1, 0, 1. And then here 0, 1, and 1 for the 21. So anything else that I need to do? Yeah, need to remove that here and then copy that a little bit higher. So 0, 1, 1, 0, 1, 0 for the 26. Okay, now let's start our multiplication. First iteration, the y0 is equal 1, we do addition. We'll add the 26, adding 26, give us the 0 here, and the 1, 1, 0, 1, 0. Result is 0, 1, 0, 1, 1, and then 0. Bring this down, 1, 0, 1, 0, 1, and 1. And then we do the shift to finish the first iteration. So shift to the right gives us here the 0, 0. Because the number is positive, we have to preserve the sign, and there's no overflow. We just shift, so this overflow register is 0, so we just shift with the 0 here, and then the 1, 1, 0, 1. Here we get the 0, then the 1, and the 0, and the 1, 0, and 1. So second iteration, the iteration 2, the y0 is equal 1. We will add the value of x, which is that here, and that gives us here the 0, 1, 1, and 0, 1, 0. So 1, 1, 1, 0, 0, and then here 1. And now we bring this down, 0, 1, 0, 1, 0, 1. And we shift to the right to complete this second iteration. Shift to the right. That gives us the 0 here, 1, 0, 0, 1, 1, and here the 0, the 1, 1, and there the 0, the 1, the 0, the 1, and then the 0. So that's the second iteration. Now we're doing the third iteration. The y0 is equal 0, we'll just shift. So shifting gives us here the 0, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, and 1. One thing to see here is that while I'm shifting, I'm filling up the upper position here with 0. Why am I doing that? Because first, we don't have an overflow, so the register C here has no overflow, but the number x here is a positive number, and therefore we have to preserve the sign, which is 0. So whenever we shift, this shift, the 0 here will also be shift with this number. Okay. This is what we call the regular logical shift. So when we shift a number and then fill up with 0, that's the regular logical shift. But when we shift with the 1, we're preserving the sign. That's called the arithmetic shift. Now let's see the fourth iteration, iteration 4. So our fourth iteration, the y0 is equal 1. Then we'll add the x. The x is 0, 1, 1, 0, 1, 0. And here we'll have the 1, 1, 0, 1, 0, 1. So that here's the 1, that here's the 1, that's a 0, that's a 0, that's a 0, and that's a 1. 1, 1, 0, 1, 0, 1. And to complete the fourth iteration, we need to do a shift to the right. That shift to the right, put a 0 here, then the 1 here, the 0, 0, and 0, and 1. And here we have 1, 1, 1, 0, 1, and then 0. So with that, we completed the fourth iteration. Now let's do the fifth iteration. We'll check the y0 is equal 0. Then we do a shift to the right. So that shift will give us the 0, 0, 1, then 0, 0, 0, then 1, 1, 1, 1, 0, and 1. And with that, we'll finish with the 6th iteration. Since we had 6 position, 6 iteration, y0 is equal 1. So we'll add the x to the partial sum. Adding the x to the partial sum give us here the 0, 1, 1, 0, 1, 0, and then 1, 1, 1, 1, 0, 1. So the result of this is 0, 1, 0, 0, 0, 1. And here 1, 1, 1, 1, 0, 1. And to complete, we do the shift. And this shift will give us the 0, 1, 0, 0, 0, 1, 0, 1, 1, 1, 1, and then 0. Yes, so now we finished the 6th iteration completely. We shift everything. And the question is now, is this our final result? No, this is not our final result. Why is that not our final result? Let's try. If this is our final result, then we're going to be having a positive number here. Means we've done the multiplication of a negative number and a positive number, and then we're getting a positive number here, which is wrong. Normally, we should be having a negative number there. So what do we need to do? Because the multiplier was a negative number, we will have to remove the value 2 to the n, which is this value here, multiply by the x. So 2 to the n is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 in the case of, and it's gonna be 6 here, and then we'll have to shift that n position. So what we do, we take this value here, and then we subtract. So we have to do now, so we have to do minus, we have to remove the 0, 1, 1, 0, 1, 0 from this partial sum. The problem when we have when we need to subtract a positive number, we'll take the 2's complement of this here and add it to this result. So what is that 2's complement? The 2's complement is 1, 0, 0, 1, 0, and then 1. Adding a 1 to that gives us here the 0, 1, and here the 1, the 0, 0, and then the 1. So we'll add it to the partial sum. Let's clean up a little bit. So we'll do plus 1, 0, 0, 1, 1, and then 0. So we'll do this operation here in order to correct our result. So what is the result of this? This is 1, this is 1, this is 1, 0 plus 0, 0, 1, and then 1. And then we have 0 here, 1, 1, 1, 1, 0. So that number here is our final result. So what does this correspond to? Let's see. Always when we have a negative number, we need to do a 2's complement in order to find the positive counterpart. So we'll have a 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0, and then 1. Adding a 1 to that give us 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, and then 0 and 0. So what is this number? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 to the 9. 1, 2, 3, 4, 5 plus 2 to the 5 plus 2. So 2 to the 9 is 512. 2 to the 5 is 32, and then 2 is 2. So that gives us here the 6. 1 plus that's 4, and 5. So I'm having 446. Let me check with my calculator that I'm correct. So that's 26 times 21. Yes. So this is our final result. So this value here corresponds to 546, and this is our final result. Yes, that's our final result. Okay, with this here, to summarize again, so just cleaning up. Now to summarize, what have we done? We had the two numbers here to multiply. The multiplier is negative number and represented here. This is our y. So we will do the shift and add in a regular way, but at the end result is not gonna be this positive number. In order for us to get the final result correctly, we'll have to correct by adding 2 to the 6 multiplied by the value of the x. X was our multiplicand, and that corresponds to shifting the x 6 position to the left and then subtracting that from this value. Subtracting means adding the 2's complement, and then the final result we got was this here, and this here corresponds to is the number 546. Okay, with that, we've seen today how to do the multiplication of two numbers where one of the number is negative. We saw the case where the multiplicand was negative, and now we've just seen the case where the multiplier is negative. And next, we're going to be seeing the case where the multiplicand and then the multiplier both are negative. Okay, thank you.